Good afternoon. Welcome to the Dorman Lunch and Learn. My name is G. Trulia. I will be your instructor, as usual, for the Automotive Lunch and Learns. So what are we going to do today? Here's what we're going to do. We're going to cover, this webinar will provide you with proper diagnostic information for testing fuel pumps for proper operation. We're going to do volume. We're going to do current ramping. We're also going to do pressure. Now, everyone loves the pressure game. How many of you out there actually do volume? Could you type a letter V in there if you do volume so I can kind of see that? Because volume is the key. You know, like in electricity, voltage is pressure, amperage is flow. Which one does the work? The flow of electrons, right? Amperage. Same thing in fuel. And I'm going to prove that to you. If we could go switch to the board. This is a special fuel pump tester machine. Thank you. Good guys out there. And if you don't, I'm going to tell you how to get one. So this particular setup right here, I'll just throw it on real quick, but we're going to be using this. So we can see we have pressure, we got volume, and we got current. We're also going to current ramp it on a scope. So I'm going to show you the first thing that you really want to do when it comes to checking a automotive fuel pump, or for that case, even a diesel primary pump. Remember, never a secondary pump, including GDI, gasoline direct injection. So we'll be using, let me shut that off, because it'll be noisy in the background. Well, when we use it, that's great. We'll be using this special fuel pump testing equipment to prove out amperage, pressure, and volume, okay? So we're gonna always start with the easiest thing first. And by the way, this tester uses lamp oil, so it's not dangerous with gasoline. I will switch out a couple of fuel pumps, by the way, and that way we can test it. How many bar commutator do we usually have, okay, in an automotive pump? Usually have. Sometimes there's variables. So if you can type that in there, type a number in, that'd be great. Can I ask you a couple of questions? So where's the first place to start? Beginning our diagnosis with current ramping. The first place we start when diagnosing a fuel problem is current ramping the fuel pump. Why? It's easy. Now, when you got to take out a pressure gauge, some of them, yes, you could screw easily on a line. Some you need to crack open, especially Euro cars and Asian vehicles. They are more difficult, and all the newer domestic cars are a little harder than they used to be, right? And we got some answers there, 6 to 8, 8. Good, I see some good ones there, 8, 8. Let me move this monitor a little closer to me so I don't have to bend down there. Good job there, guys. Okay, so low to average current, high average current, abnormal fuel pump waveforms alert us to many potential fuel supply problems, okay? Now, those problems could be maybe the pump is not all the way into fuel. It could have broken off, but that's not all that common. We could have a problem with a pickup tube, a hose. Have you guys come across extended crank? This used to be big, especially there was a TSB, technical service bulletin, on Jeeps. You try to crank it over, then finally goes. And if you wanted to know if you had a drain back problem, because you could have a bad check valve, right? But what you would do is cycle the key. Turn the key off, turn it on, fuel pump runs for roughly 2 seconds, right? We're talking primary pump in the tank. Then you would shut the key back off, hit it again, let the pump prime. The third time, you try to crank it up. If it starts up instantly, that means you got drain back. Now, a lot of people always thought that was the check valve. Sometimes there's separate check valves. Most of them are built into the pump, but people would change the pump. What didn't they change? What do you think the problem was? And it had to be in the fuel tank. What do you think the problem was? This is with the TSB. I'll give you a second to answer that while I take a sip of my water. What do you think that was? If you get the right answer, you could win an unbelievable Dorman t-shirt, okay? And we may throw a hat in. So, okay, someone said a sock. Anyone else? A hose. Okay, that's the right answer. Bill, type in your email. A hose. He's the first guy to come up with it. The hose became porous and the fuel would leak right out of it, okay? And by the way, everyone likes using screw clamps. You know what I'm talking about? The screw clamps, the little band ones where you can see rubber come through. Never, ever over-tighten that, because if you over-tighten it, what you're going to do is fan, the tube is round, the hose is going to fan out like this, and you may get fuel to leak back. Notice, all the new ones come with either the old metal crimp bands, that means they go on once, they could be used one shot, or the new plastic ones that click in like a wire tie. Those are the right ways of doing it. Now, easy place to go is like we're showing you here. Find the fuel pump relay and take it out and use a fuse lead. Now, what terminals are we across here? First guy can get a t-shirt. First guy can get a t-shirt. And the last guy, if you didn't type your email in, you want to do that if you want that Dorman t-shirt, okay? So what terminals of the relay are we across? I don't see anything else. Okay, 3087, first guy, quick fingers there. Anthony. So Anthony, put your email in, and the rest of you is thank you. So 85 and 86 is the low current part of the circuit, as you know. It's going to build up a magnetic field. It's going to pull 30, which is battery plus power, into 87, in this case, the load, the fuel pump. So that's what we're looking at there. That's the first place to do it, and it's always safe, just in case, to use a fuse lead. So beginning our diagnostics here, restrictions in the fuel supply circuit, clogged fuel filters, a crushed line. We all know people don't know how to set vehicles up correctly, and I've seen this. I've seen people leave crimping pliers on, whether it be plastic ones, like the one I'll pull from over here. Where is it? Of course, I'm looking for it. Like this right here. I've seen people leave these on. Vice grips, the little crimping tool from maybe your run right, your BG, your wind setup, where they tell you shut the fuel off so you don't get the chemical in the tank. You find them on there. That can be a problem, right? Restrictions at the fuel pump inlet. The sock could be clogged, okay? You could have problems in there. Tanks do come apart. Notice we're using a lot of composite tanks now rather than metal tanks. Metal tanks would tend to rust, flake, get caught up, right? We would also have a clogged fuel filter, but where's today's fuel filter? That's right, in the tank, no longer serviceable outside of the tank. You could have worn brushes. So worn brushes, we would see something here. This is a picture of a good current ramping fuel pump. What is the average for a shirt? What is the average current ramping at idle on a let me say this, on a non-computerized pump? Because computerized pumps look at things like VSS, vehicle speed, Prindle, park reverse drive, and grams per second. So they're going to run at lower amperage, but we're talking about on a and then I'll give you computerized pumps, what they run at, okay? So a non-computerized pump, what is the average amperage? Type that in there. Okay, 5 to 7, we're getting close. We're close, but nothing yet. 3, 5, nope, keep going. Let's see the first guy to hit that number.
8.
Nope. Now, if we had some Vortex motors, then we would be 9 to 11, but we are not getting.
15?
Nope. I'm looking at all of these here. 5, getting close. All right, so closest guy so far, if I don't see it, would be Carl Labor. All right, Carl, 6. 6 amps is pretty much normal. 6 amps is a normal pump. And write this down for a computerized variable pump, which all the newer vehicles that you're working on, at least the past 5 to 7 years, are going to be computerized pumps, and that's why there's a module for them. Again, when you put a module in, they usually need to be programmed unless you buy, I'll give Dorman a plug. If you guys don't program, they have a little programmed chip that comes with it that makes that module operate correctly. So computerized pump, it could be down to at least 2 amps or so. 2 amps or so. Good. And if you have any questions, please type it in the chat box. A lot of you guys were close, but he was the closest. Worn armature bushings. This is common. How do you get worn armature bushings? You know when you see that guy with the tank under a quarter, you know, it's just about out of gas. Just like a well pump. If you ran a well pump low on water, you're going to burn the pump up. You run a fuel pump low on fuel, which helps cool the pump, you're going to burn it up. And what happens at the end of a pump, what we have, where is that pump? What we have in these things, like this pump here, we got bushings in here that go near the end. So let me put this close to me. Okay. You got a bushing here, and the nylon bushings heat up, and the nylon bushings tend to melt, and rather than this thing going in a perfect circle, it's going to wobble. Okay. It's going to wobble because in here is a magnet. And of course, now we got three-phase fuel pumps, but we're just talking regular fuel pumps in this particular one. This is your armature. Okay, so the armature here is every one of these things where you see the winding go through. So this one is not a 8-bar or 6-bar. This is a 12-bar pump, okay? 12-bar pump. And, you know, usually the German manufacturers do a better job with putting bearings in there. So if you get a Pierberg pump, some of the Bosch pumps, some of the Siemens pumps, those pumps are better than well, not inexpensive, but the way they build most of the other pumps you're working on, a nylon bushing. Run it low, heat transfer to a nylon type of bushing, what do you think is going to happen? Rather than going perfectly round, like I just said, you're going to be wobbling once it heats up, okay? So, ooh, excuse me. Oop, I went backwards. Sorry about that. Worn or burnt commutator bars, that can happen. Restriction in the fuel line, stick in pressure regulator, that would give us higher amperage, correct? So you always want to check to what it is. This is a quick, fast check. 9 out of 10 times you could easily connect to one of the wires, positive or negative near the fuel pump, or go to the fuel pump relay like we said. In most cases, I'm not going to say in all cases because I know the real world. When you're working on the car, sometimes they tell you number 8 is the fuel pump relay, and you go there, it's not the fuel pump relay. But we usually find in our shop, we'll look up, use AllData, ProDemand, Identifix, or Motologic. You could find out where the relay is in case it was marked wrong or not marked at all. Okay. Now, for you rocket scientists out there, I put this in here because this is the diddly deal that a lot of you like to know. I want you to write here on slide 8 that this is a pump that we have 100 millivolts per division, as you can see right here, equaling 1 amp. So your amp clamp would go on 100 millivolts per division. You would then count it from the bottom. If this was our 0, 1, 2, 3, 4, 5, 6, and you go to the top. This would be a 7 amp pump. So we would say this is our 0 because this is most common. Question here. Now this is, again, non-computerized pump, but you can still do the math if you want it. There's 1,000 milliseconds into our 15-second span because there's 2 milliseconds per division. We're counting here from the bottom going up, and you count this across, 2, 4, 6, 8, 10, 12, 14, that'd be 16. So 15 milliseconds divided into 1,000 milliseconds. Why into 1,000 milliseconds? 1,000 milliseconds make 1 second. You divide that, and you can do this on your phone, you get 66.66 revolutions per second. Times that by 60 seconds in a minute, that pump is running at about 4,000 RPMs, or to split hairs, 3,999.96. Personally, I don't give a rat's butt about that. Why? Because this is on a non-computerized pump. If your pump thinks the grams of air are off or you have vehicle speed on it, this is not really going to help you. But I wanted to show you that because people always ask that in a class that I'm doing. They go, oh, how would you do that? That's technology from years ago. You don't care really how it's spinning. We're going to show you what you need to diagnose after the current rampant. Is this a good fuel pump? Look at it carefully. Is this a good pump or a bad pump? What would you say? Good pump or bad pump? Put a B or a G. A B or a G in the chat box, please. B or G in the chat box. And I know we got a little delay here. Good or bad pump? B or G? B or G? Anyone? Okay, we got B, 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 B.
One good.
One G. Hey, Mary. Mike, okay. B, 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 B. Okay, this would be a good pump. Why is it a good pump? Now, a lot of people look at little anomalies like this. Oh, there's something wrong there. This could be a pump breaking in. What you always want to do is, you see the top of these? They're all pretty much even. If you have a pump that's more than one box difference, so let's say this was down here and you had one go up here into the middle, or you had one of these drop down to here and then come up, that would mean you have an armature problem, okay? Now, when we go on the board, I have a bunch of pumps here, and you're going to see different amperage. You may see one of them with a bad armature in it, but sometimes if they don't do the right amperage, we're using this off roughly a 6 amp setup. So now here, many vehicles use 2-speed fuel pumps. Now, that used to be the case. And you know what the first, who knows what one of the first, at least on a domestic car, the first variable fuel pump used on a vehicle? If you get that right, I'm going to give you a shirt and a hat. What product? Okay, so, you know, is it a Ford, in other words? Is it a Toyota? Is it a Jeep? Whatever. What vehicle had the first variable speed fuel pump? And we'll talk about that. So many of them have that here. The diagram shows a sample of a 2-speed fuel pump right here. Okay. So this is something that the Europeans used at one point. The diagram shows a sample of that. In one relay position, the pump receives full voltage and runs at a high speed. So we could see you can be at lower amperage and then go up to higher amperage. So low speed, high speed. Why would they even want to do that? Why would they want to do high speed, low speed? We're going to show you a bad pump graph. We will do that. I'm looking here as I'm waiting. Okay. All right, someone said Corvette. Someone said Chrysler. Okay, so we're looking for the first one, and I'm going to tell you how they did it. Very, very simple. I'll give you another few seconds here because, you know, we're on lunch here. So we can't go forever, right? Not a Buick, not a Beamer, not a Chevy, a Ford, a GM, a Chevy, a Chrysler, no, and more no. Not a Benz, not a Ford, not a Caddy. Very simple. I bet you've worked on these things and seen it. Nope, not a Tucker. Okay. Write this down. The company that did it was Jeep. Did you ever look at a Jeep back in 88, 89 when AMC, just before they sold it to Chrysler? They had a resistor block like the old resistor block in the old days. And what do you notice about a Jeep grill? It has a lot of airflow going through it. And when we heat up a resistor at idle, where would the current be going to that pump? Where would the current be going to the pump at idle? We heat that resistor up. And then as we drove down the road, we cooled the resistor. Where would that pump be? I don't know if that guy said Jeep after the Renix. One guy said Renix. Okay. The Jeep guy, type it and we'll give you a hat. I don't know if I wasn't paying attention at that point. Doreen says after, but we'll give you. Type your info in there for a hat. Okay. So when you're at idle and the resistor gets hot, because air can cool the resistor, right? The current flow would be low. What would be the fuel volume and pressure coming up? It would be lower. Drive down the road, we get airflow going through it. When we cool the resistor, we get higher current flow. Therefore, that pump would produce more pressure, more volume. Does that make sense? Okay, so that's what we're looking at. Now, here's a bad pump. Let me blow this up. So off my old Fluke 98 from years ago, it don't matter what scope you have it on. We're not going to use that today. We're going to be using an E-scope today. But every 100 millivolts equals an amp. If this is ground, 1 amp, 2 amp, 3 amp, 4 amp. It doesn't even make 5 amp. And what do we notice here? We do not have good consistent humps. Okay? Now, conversely, if we go to the good pump, and is this good or bad? And I want you to carefully look at this. Is this good or bad? Well, we know it says good, but how many amps good? How many amps good? How many amps good? First guy to get the answer gets a t-shirt. I'm in a t-shirt giving mood today. Of course, they'll probably fire me after this, but we'll give enough t-shirts. I'm only kidding. They're cool with giving stuff out.
3 amps?
Okay, 6 amps. Christopher is right. Why? Why 6 amps? Christopher, type in your email, give you a t-shirt, dude. Good job. Because you know what you need to look at? We are 200 millivolts per division. 200 millivolts per division. Here is 0, 2, 4. You go by the height, 6 amps. And by the way, that's a perfectly good pump. When you do put a new fuel pump in, remember, pumps have a break-in period. Now, the other thing, since your amp clamp is a big-ass magnet, I want you to write this down. Since it's a big-ass magnet, when you go to something like this, if you see more like hashy stuff coming up and down, this one was just a bad pump. I don't have in here, when an alternator diode goes bad, you can pick it up right from your fuel pump. Okay? One day when we do some lab scope stuff, I will throw that slide in there. I found quite a few problems with alternators like that. Okay? Here we got another one here. Here's a good OE pump. And again, if you go 200, you're at 6 amps. Go by the height. Here, we're at 100 millivolts per division. And if we go here, 1, 2, 3, 4, 5, 6 amps. But it looks totally different, doesn't it? These are called pump signatures. Doesn't mean the aftermarket pump is junk or anything, okay? It's just a different signature of the pump is what's going on. That's it, okay? There's no other problem. Remember always to zero an amp clamp near where you're testing. So I'm going to show you that on the board there just in a little bit, okay? Now, I bet you didn't know this. First of all, we have 100 millivolts per division for channel A. This is channel A, and this is A on DC. So you got 1, 2, 3, 4, 5, 6, 7, 8. This is an 8 amp pump that has a problem, okay? This was off a Vortex that should have been 9 to 11. So a GM Vortex motor with 60 PSI to start the vehicle. This was bad. Why is it bad? It's more than one difference here. And you see this dip? And you see how we go down? We're going to have a problem with that pump. Now, let's say someone broke your amp clamp. You know, like, oh, my guys have done this. Close the hood on your amp clamp. Now, I have a load of them, but years back when they only had one of them, and they closed the hood on it and was broken, uh-oh, or your battery went dead and you don't have another 9 volt in your shop. Can't do it. Well, you may not be able to actually tell the exact amperage of the pump, but you see this? I'm on AC voltage. AC voltage right there. Above and below 0. And you see here, this is ground. You see how we're going up and down? Does it look like it mimics the waveform above? Take a good look at that. I want to blow that up. Take a real good look at that. Come on, fingers. Does that look similar? Sure it does. Now, when you use AC, you cannot, okay, you cannot really tell the amperage, but you could put your meter, your digital voltometer, in series with 30 and 87, right? And if you did that, you would see the current that it's flowing. But that doesn't mean everything, right? We said the signature of the form. So you see how we have the exact same dip, okay, We have an issue right here, right there, and the rest of it looks pretty much similar. How are you going to do that? How would I do that? Well, I'm going to tell you how we would do that. And I'm going to show you, because we're going to actually do that on the test board. The positive and negative lead ends of the scope are connected to the power and ground of the fuel pump. So if you don't have an amp clamp, you can still capture a waveform. Does that make sense to everyone? Okay. If that makes sense to you, I'm going to show you, again, seeing's always believing, right? That is an important thing. Now, this is a great chart, especially for you guys that current ramp. So if current is low, pressure is low, volume is low, low fuel pump circuit voltage. So what's that mean? You have VD, not you personally. The fuel system, the connection, voltage drop is what we're talking about here. You have corrosion. And this time of year, I mean, today I think we'll get maybe our first snow, a couple of inches or whatever. But in most places, in the real world, you've been getting some snow, right? And they use salt and all that. How many of you have opened up the fuel pump, or I should say unplugged it, and you see behind the rubber boot, in the wire connection, everything's corroded? What you need to do before replacing that pump, whether it failed for amperage or current ramping test, you need to clean that all up, okay? You use that dioxo or dioxide spray cleaner. I forgot the exact name of it, red and black can. That's a very good cleaner. After you're done cleaning it, you put Stable 22A only on the male pins. Stable 22A is a contact enhancer. That way, if you do it and you see the pump gets back to normal life, all you had was a voltage drop. You did not have a bad pump. No need to change a bad pump. When you're changing a pump, write this down as well. You need to order a new locking ring, whether steel or plastic. And by the way, guys, stop with the hammer and chisel on the damn thing, okay? Even on a composite tank, if you start banging around, you could crack. That area is very thin. You should get the right, I don't know if you want to call it a socket or tool that locks in. They have universal ones. We probably have 10 different ones here for the most common cars, and that includes a couple of universal ones. You need to do that. Get a new gasket. Use an air vacuum, not an electric vacuum, to suck any dirt off the top of the tank before you remove the ring. Okay, we start banging on it or turning it. And then as you're actually taking the ring off, suck it, because any silt or dirt that goes down into the pump will destroy the pump. It'll go through the filter and grind down that armature or brush and wear stuff out, okay? So here you could have, with that low, 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 fuel pump inlet restriction, clogged inlet sock, weak pump. Next one, current high, pressure low, volume low, restriction fuel supply, including a plug fuel filter, or has high mechanical resistance. Mechanical resistance meaning the armature in the brushes or something is binding up. The bearing or the end where the nylon bushing is could be a problem. Current normal to low, pressure low, volume low, fuel leak inside the tank, and if it was one of those older Vortex, they used what they called a pulsator, almost acting as a muffler so there is no noise. Now, the last one, current high, pressure high, volume low, pressure regulator stuck closed, fuel loop, return line restricted. Write that down here. Here's where you may be lucky and get yourself a new pair of vice grips, which you should never crimp a hose. Even if it looks rubber, it may have nylon inside that rubber. Always make sure what you're using. We're going to show you this particular tester here, but what we use in our shop now, even though I have a few of these, we use the one from Mityvac. And if you ever look at my videos when we're in the shop, in the back right of the corner, yeah, if I'm looking at it, well, it would be to my left in the corner, you'll see a Mac Tool one. That's Mityvac. Mac Tools, I had done something for them and they had an insert that I put it in and I never took it out. That is a good tester. You can get that through O'Reilly's, Napa, CarQuest, Advanced. They sell them all over, about $600 or so. Great thing to have, because that's what really counts. Okay, so now let's do it live, right? So now, doing it live, this would be like just in your shop. So we're going to switch over to this camera. We're going to look at pressures here. Don't worry about the vacuum gauge. We're not going there. We're going to look at volume here, and we're going to look at current here first before we go on a lab scope. So let's put this on. What do you think about this reading? Can you all see it real good? I got, okay, so Ed Smith, current low, could be a bad fuel pump ground. Yep, very good, Ed. That's a good possibility. Anything else? We got about, I think it says about 4.5 amps there. So if you see something else, let me know what that something else is. You're right, typing it in there, Peter and Tom and John. That's all correct. But first of all, what do we know about our fuel pump pressure? Is the pressure good? So let me kind of blow this up a little bit here. So look at that pressure. We're only at 30 psi. Then I want you to look down here, and let me move that down a little bit. A little hard to see that ball, huh?
Can't really see it.
Yeah, I don't know why they can't see it. I've seen it before. So that ball is right here. And if we cross that over, we're roughly about 4/10 of a gallon, which is, let me see if I can kind of block out.
It's the light on the machine, Jay.
Oh, it's a light on the machine. Beautiful. Usually that's supposed to help you see it.
Well, not in this case.
How about that? Is that a little better?
The ball.
They can't see the ball?
Let me see, where is the ball?
Ball's right here.
Cannot see it at all.
Let me try something like that. Can they see it
No,
now?
it's the light on the machine.
I mean, they have the light on the machine so you can see it.
But you can't see it. Can you take it off? Would it still work?
I don't know if I have that much hose. Let me see.
Because there's the light. You take it off, you can see it.
Yeah, but I can't. I got too much junk attached, too many hoses. Let me see if I can go in a little more. Hang on one second. You know, it looked good before, but I think a little bit of the light from above is giving us a problem too.
Should we shut it off?
Shut the light off for a second.
No, worse.
Wow. How about a different
You'll have
angle?
to tell everybody.
All right. We can't spend a gazillion hours on that, but let's say. No, you can't see it for some. I guess the LED light behind it is bad for this camera.
Yep.
Sorry about that. But you'll have to believe me.
Just
Where?
point, and they'll know.
Yeah. So the ball is basically right here. So now I'm going to raise the pressure because let's say our spec is 40 pounds, right? So 40 pounds, let's take a look. Right there, 40 pounds. The amperage is 6 amps. Let's look up there. Okay.
Somebody said adjust the white balance on the camera.
You can't do that on this camera.
Just point.
Okay. Now our current is all the way down here. You can't even see the numbers on this. Okay.
Someone says put a piece of paper behind it, but that would take up the whole friggin' time.
Well, you know, I'll try real quick. We'll try to throw a piece of paper behind it real quick. Hang on. That's a good idea. Let's see if you can you drop it down?
You need a thin piece of paper.
I don't know what this is, but it's going to become a thin piece of paper now. Hopefully it's nothing important. Got it. Ah. How's that? No, I still can't see it.
Pull it up for a minute. Take that out.
I think you can see a yellow paper. I don't think you can see it any better. Oh yeah, you can. Very good. Now how's that? Can you guys see that? We have to put paper behind it.
All right, go ahead.
Okay, so now we got amperage over 6. We got 40 pounds. Is this good enough? Now, for you guys that, let's say the spec on a car was 40 PSI, okay? If it's 40 PSI, is that pump good? That's my question. Is that pump good? And thank you for Doreen coming up with a little piece of good paper, unlike my junky paper, I guess. So what do you guys think? Is that good? One guy says, you better give the guy a t-shirt. Okay, it's no good. And here's the reason why it's no good. We have poor volume. So volume could be a huge problem, right? Now, let's current ramp this pump. I'll take some of the pressure off it. And we're going to switch over to our E-scope. We're going to take our amp clamp and we're going to go to the first click, 1 MV.
Can't see it.
1 MV equals 10 MA, or the newer ones all say 100 millivolts equals 1 amp. And that's what this is going to be. We're going to zero it near the wire, okay? Our wire right here. We're going to put this,
They can't see it.
okay, I got to zoom out. Okay. One more zoom in. So I'm going to take this, I'm going to zero it near the wire, put the pump running, and I'm going to put my amp clamp, making sure the jaws are closed. I am now going to go to the scope, and my scope I have on every 100 millivolts equals 1 amp, or you can go by the rating on the particular scope, and in this case it's the 20 amp rating. So here's our current down here. We could change that if you want to see more ramping by taking the time. And now you can see the humps. What I have on the bottom here, which is very, very small, is the voltage of that pump. Okay? Now, that being said, everyone see the yellow? You can't buy this fuel training aid. It was made for me by Larry Gouge, the inventor of the smoke machine. So now, everyone see where the pressure is? The ball's down here, right? Everyone see the ball down there? Watch this. I'm going to put more pressure. Look at our current ramping. You see what that is? I'm going to have to go up a box. And you notice it's still pretty far down there, right? Oop, got to go the other way. Go down a little more. And let's bring the bottom up. So you can see the pump is going at a higher speed. You see how it's growing across real quick? I will change that pressure. You see how that went up? You hear the noise? Now I'm going to drop it. And you see how it's slower going across the screen?
They want you to zoom into the scope.
Zoom into the scope?
Yep.
Okay, so this is at a slower speed. And I think you could hear the hum in the background of the fuel pump, right? Mm-hmm. Now I'm going to change the current. They see the speed and how the amperage changed? And you hear that thing pumping out? So we're going to leave it right about at this speed. And you really don't see the voltage. I'm on power and ground here. So I'm going to go into deep record where you don't need to set anything up on this particular scope. I'm going to put my 2 channels on. You see the greens here? These are my channels. I'm going to hit start deep record. I'm going to stop this. I'm going to shut off the noisemaker in a second, just so it's easier to hear me. Okay. So now I want you to look at the scope. Red is the voltage. I am going to zoom out. I'm going to use the zoom window. I'm going to zoom out again. Use the zoom window. Now, can you see the amperage? This is the voltage. Now, of course, I can still zoom again to show you the pump, right? And I can use the pan handle and then zoom out so we can get the yellow in the screen. Oop. Sorry about that. One good thing is when you mess up, it's real nice that you can just go, you know, zoom out. Then we'll use the zoom window. We'll zoom out again. And you can see how the amperage and the voltage are starting to look like each other. So just like I showed you on that other scope, this is more flat right here, but I think you can get the idea of how you can put them together and see if you got a bad pump. Any questions on that? Now we're going to look at a couple of more things here on the pump, get away from the scope stuff. If you have any questions, please let me know. But we still have time left, which is great. Let me adjust this thing here and zoom out a bit. And one zoom in. All right, move this, straighten this all out. And I hate looking backwards. Boy, it's tough. Drives you nutty when you're looking backwards. All right, so now I'll just move this back a little bit, give us a little more room here. And I'm going to show you where the tank is on this thing. So I'm going to take my amp clamp out of here so I don't get any lamp oil on here. I'm going to get rid of that, move that to the side. And by the way, here's where the voltage reading was from, power and ground. Okay, that's how I was getting a current reading, or a signature reading, I should say. And what we're going to do here is we're going to go into this box. Just get myself a couple of rags, and we're going to change a pump out. We can change a few pumps out so you can see what different pumps would look like at the same type of current flow through it.
So we can't see the pump.
You can't see the pump yet, okay?
There you go.
There's the pumpies. All right, so I got to take a dive in there. It's time to go swimming, okay? So let me unplug this thing. And here's the screw clamp that I was speaking about. These screw clamps you got to be very careful with. If you over tighten them and rubber starts coming through, then you're going to have an issue. Okay, so let me take this out.
I had a question while you're doing it.
Yes.
Would you be able to see a fuel volume issue by measuring pressure under load, i.e. power braking?
No, pressure is pressure, volume is volume. So you're really not going to see a lot. And by the way, here's what your screen looks like. Okay, they should go on the end of the pump. This is your sock. You know, a very, very, very small amount of dirt can get through there, but fine silt can get through there. Here's our other pump. So we're going to try this pump here. There's a positive and a negative. So we're going to plug the positive lead in, the negative lead first. We're going to do the positive lead here. And by the way, there's also a lesson like in electricity with pressure and volume, right? I'm going to put the hose on. I'm going to lock this clamp up real quick. We'll submerge that baby. Stick that down so in case it pops off, it doesn't get me all wet. Should lock the top for safety reasons. And let's run this baby. So I'm going to move this up because you don't need to see that anymore. Let's run this pump. First of all, the ball is up here now. You can't see it. Do we have another yellow piece of paper we can throw in there real quick? Okay, Doreen's to the rescue. Beautiful. Now you can see it, right? Yep, you can see that ball right there. Now at a half a gallon a minute, I want you to write this down. A 4-cylinder, non-supercharged, non-turbocharged vehicle should have a minimal of 0.4 of a gallon over here. A 4-cylinder, turbocharged, supercharged, 6-cylinder, and 8-cylinder minimal should have 0.5 of a gallon, half a gallon a minute. If you don't have that, you got a problem. Now here's the other thing with pressure. You all looking at pressure? We're going to do cavitation. Cavitation of the pump, and this is going to be severe cavitation, but you may still get pressure with cavitation. What you're not going to get, now look at the glass. You see those bubbles? Everyone see those? Now these are severe bubbles. Can everyone see those bubbles?
No.
All right, so I got to zoom in. Watch the glass. Here we go.
Okay, we see something.
Watch the bubbles.
Yep.
That's called cavitation. Your pressure would really not show you much there. Now we'll take a quick look on the scope here of, go ahead.
What voltage?
What's voltage?
What voltage? Question mark.
What voltage? What do you mean by what voltage? If you have low voltage, your pump would have an issue, right? So right now we're going to take this pump, we're going to look at this pump, or maybe just go back here and make life easy for them. Okay, so now I got to get this thing up here more. So here's the pump. Let me change the time.
We don't see that.
Well, so here's this pump. Looks very similar, but what's the amount of amperage compared to the other pump? We're at 40 pounds. And remember, we had the other one at 40 pounds? Look at the, come on. Look at the 40 pounds, right? Look at our current up here. We're 6 amps. And look at the volume. So here you would have a pump that's pretty damn good. Why? Because we're hitting, oh, we went down actually. We're hitting a half a gallon a minute. This is flow in gallons per minute. So we're a little lower there, okay? But if we had a half a gallon a minute, then basically we would have a good pump and the amperage would be different. Does that make sense to everyone? Let me switch to another pump and I'll just shut this for a second. Type your questions in there, Dorian, let me know what their questions are as I'm unscrewing this pump and unplugging it.
Well, the person that said what voltage are you running a volume test at?
Oh, I'm running the volume test at system voltage, which would be, 12 to 14 volts is what I'm running. Okay. Thank you for that question. Let's see. We'll try a different pump. This one looks good as any other. So there's another pump. Oh, this backward stuff can drive you crazy. Another pump I'm throwing in. These are all different pumps that I keep around that have failed in a car. And what type of problems would you have? What code would be the most common if you had a pump that wasn't delivering enough fuel? For a t-shirt, probably the last one for this Dorman Lunch and Learn. So I'm connecting this up. Okay, I'm connected in, put it down, lock her up. Let's see what happens. Hit the switch. You see that aeration that just happened? Okay, so you got a lot of cavitation there. You're at 30 PSI. Our current ramping on the scope the waveform looks pretty damn good, but the amperage is low. This pump is only at 4 amps, okay? Only at 4 amps. So when you go to diagnose a fuel pump, and we'll check one more out before we hit the slides back. Let's look here. That volume. And is our volume good? No. A lot of these pumps that I have here, or all of them, fail for some reason, but most of them fail for volume, not for pressure. And that's usually what messes people up. They can't get that, there is a problem with, I have 50 pounds or 60 pounds of pressure that the manufacturer is asking for. How could it be bad? Because you need volume. And anyone put the answer in for what code will we have?
Yeah, E0171.
Very good. Get that guy's email.
That's Gene Mark.
So get your email in there, dude. We'll get you out a t-shirt. I like when you guys participate. Now, not only do we do Dorman Lunch and Learn, both now heavy duty, which Swede will be doing in a few weeks, and we'll send an email out. Pass that on to your heavy duty friends, or maybe perhaps you want to watch it. These are always up on the Dorman Training website or on attsttraining.com under free videos free, Dorman Lunch and Learn. This thing should be up probably sometime later today or tomorrow. So, okay, I'm putting this other pump in. I'll show you what it looks like in a second because you can't see. Go back to this camera. So now we got a fancy blue pump, okay? I'm going to stick this in here. Don't even know if this one works, but we'll find out in a second. Let me lock this doohickey up. And we appreciate your attendance. We know we want to get you back to lunch. Let's see what goes here. Dead pump. Where did the amperage go? It's pinned. Look at the amperage up there. And no noise. Dead pump. And if we look at current ramping on the scope, the line is all the way up there. Watch the line on the scope. I'm going to flip that switch. I'm going to attempt to flip the switch. Let me get on the other side of this. It's like playing musical chairs here. So I'm trying to do multiple things. Switch off. Amperage went down.
Well, we can't see.
Amperage went down. Come on. Stop fighting me. Here we go. You see how that amperage went up right away?
Yeah.
Look at that line. Off, on. So right there, you could see when you could test the pump, you could actually see what's going on. Let's see if you have any questions. So P71, Is there a generic compensation chart around for specs? Okay. The generic specs for, if you're talking about amperage, most pumps are going to pull roughly 6 amps, as we said in the beginning. A computerized control pump is roughly going to pull 2 amps to start with, and then as you were driving down the road, there'd be. Years back, my buddy Don Schnell and myself did something called the Attacks program. We did over 170 cars, but you're talking back in the 90s, okay, back in the 90s when there was a lot of different vehicles around. I would say on most of the vehicles you're going to work on, you're going to see that low at idle because it's computerized, and then higher later on. Vortex, because they had pushed 60 PSI out to start the engine up, was always a 9 to 11. Some of the Ford pickups that needed high fuel volume, it's going to be up there about 11 to 13 amps. So a chart that's out there, no one really makes it. You got to test it, is what we did years back. And someone like Tom Petty down there in New Jersey helped. Jim Lender, you may have heard of Jim Lender, the injector guru guy. So a lot of us had the same scope at the time, the LS2000. It's always important to make sure you get the same signature from the same scope. And any other questions you got there? Let's see. What about brushless fuel pump motors? Well, we're not speaking about that in this particular episode because there's not enough time, but yes, brushless is going to be the way to go. 3-phase, just like everything else, including EPS. We'll visit that at some time in the future. Everyone needs to get back to work, so we're going to say here a few things. Next month, LabScope Diagnostics with instructor Scott Manor, tstseminars.org. Don't forget, you haven't signed up yet? You need to sign up for the TST big event. Saturday, March the 18th in Terrytown, New York. We get people that come from all over the country, even from other countries. So why haven't you signed up yet? You get a free Android tablet, hot breakfast, hot lunch. This year, for our 20th year, hot dinner and drinks after the event. You can mingle with different instructors, not only the ones that air, but the ones that come out. Like my buddy Dave Hobb, for example, will be there. You can chat with him. Our buddy Don Schnell will be there. Pete Meyer will be there. Kenny Zanders will be coming out. So we got a whole bunch of different people that will be there. So come out, 3 great instructors. You get an Android tablet to keep besides all that. Upcoming months, besides Keith Perkins and Gary Smith and a mystery, a special instructor at the big event. Then we got Zanders in April, Scott Brown and Brandon Steckler for the following months. And we want to make sure you are aware again of our Dorman Lunch and Learn HD. That'll be in the middle of next month, I believe. And we will have the Tesla one. As soon as I get confirmation from the Tesla tech, because we are going to be using the factory software, we will get that up as quick as we can and have you come out. Do you guys like this? Did you find that this was helpful? If it was helpful, a Y. Helpful, a Y. If you thought it was a waste of your time, give me a letter N. And if you thought it sucked, waste of your time, N or Y. And I want to thank you on behalf of myself, G. Trulia, and Dorman Training. So we'll see you next month. Get back and eat your lunch and have a great day. If you type any other questions in there, I'll be more than glad to answer them. Thank you so much. Take care from New York. Have a great day.